Solve the inequality. So we're going to solve an inequality using absolute values. So we have just general rules here. If we have something of this form, then it breaks it up into these two statements, right? Let's just talk about this one just a teeny tiny bit. So maybe hopefully clear up a little confusion if you've got some confusion. So let's think about an easy example with an actual number in there. So if I did, here's an example. So absolute value of x less than, I don't know, 2. So we know what this means, right? Absolute value is distance away from 0 on a number line. We can draw a picture. Here's 0, here's 2, here's -2. So all the numbers that are less than 2 in absolute value have to be less than 2 units away from 0. So they're all in here, right? So it's between these two numbers, and it doesn't include those endpoints, but they are there. So what we're doing up here is, I guess we could sort of think about it as taking this interval apart. We want to have all of the values that are less than 2 in absolute value. Well, if we look at the interval and we maybe think about it in a slightly different way, we can think about this interval as an intersection of two intervals, right? So if I have this interval here that goes that way, that would be -2 to infinity. And then I have this interval here that goes the other way. That would be the interval -infinity to 2. And if I take the intersection of those is what I want, right? So it's -2 to 2. And that's, that's the way we would construct it, right? We want to construct it with an intersection, right? And that's the and. The and statement is an intersection. Similarly, if we think about the greater than inequality, if we wanted all of our values to be greater than 2 in absolute value, then that means that we want it to be more than 2 units away, right? So here's 0, here's 2, here's -2. So now all of these solutions are going to be either over here or they're all going to be over here. So this one is a union. We want everything that's in this interval and together with everything in this interval, which is a union, so or, right? So either x would be less than -2 or x has to be bigger than 2. So that's kind of why we're using these things. So we could split ourselves up like this. Okay, so let's get back to the task at hand. We have a less than inequality, so we're going to use this first relationship here. So we have absolute value 7x minus 11 less or equal to 10. All right, so we have that less than relationship. So we're going to just, first step is just split it up, right? So this means this. So we're just going to rewrite it in a different way, right? So this guy means that 7x minus 11 has to be less or equal to 10, and 7x minus 11, and observe what we're doing. We're switching the sign and we're making this thing negative. So we switch the sign. Instead of being less than, it's now greater than or equal to, and we switch the sign. Whoops. Sorry about that. We got a good thing going here, so we don't need to stop the video. All right, so we got this guy splits us up into these two statements, this compound inequality, and we switch the sign and then make it -10. So now all we have to do is just solve these individually, and we're pretty much home free. So this guy, we can do that, add 11 to both sides. So we got 7x less or equal to 21, and we can do the same thing here, add that 11 to both sides. We got 7x greater or equal to, add 11 to both sides, we're going to have 1. So then this says x less or equal to, we're going to divide both sides by 7, so that's a 3, and x bigger than or equal to 1/7. So our solution set is all of the numbers that are less than or equal to 3 and bigger than or equal to 1/7. So if we want to draw a number line just to help us out in drawing our interval or constructing our interval, we want everything that is less than 3 or equal to 3, so that's closed dot and goes this way, and x has to be bigger than or equal to 1/7, so closed dot that way, and we shade everything in here. So if we needed to draw a picture, there's our nice picture, but we wanted to give our solution as an interval, and there it is.